Hello my dear friends, what's up? Welcome back to your channel of learning mathematics, your channel of learning mathematics. So we'll continue with exercise 5.1, continuity. So last time, if you remember, we stopped at question number 18, I guess. So we'll continue from question number 19. So let's jump into the question of continuity. This is a big exercise. So yeah, take out your pen, book, paper, and then let's begin. And then yes, if you still haven't subscribed yet, please do subscribe. That's really going to help me a lot. And yes, do like the video. Also give me a like, that will be really good for motivation. And yes, kindly a request also, please do share with all the students that are in need of this particular kind of a channel. Alright then, so let's begin. Show that the function defined by g of x is equal to x minus greatest integer function of x is discontinuous at all integral points. Integral means at all points which are integers. Okay. Here here x denotes the greatest integer function less than or equal to x. For that, of course, we will need a small concept of greatest integer function. So if you still remember, greatest integer function would be, is already defined here, integer less than or equal to x. But if we check at the point a, then the greatest integer value function of a would be a, right? Greatest integer function of slightly less than a. Remember, every now and then I remind you, this h is a very small interval. So maybe for example 1 minus 0.1, so that would be 0.9. So that also, the greatest integer would be the lesser integer that is less than or equal to, so that's going to be a minus 1. A minus 1 means, see, if this is a function 0.9, so that's going to be what? Minus 1. 0. The next integer, of course, not like this, the value will be what? 0. Again, for example, like 2.2. So the greatest integer function for 2.2, we write what? We will be writing 2. That's the integer that is less than or at the most equal to 2.2. So we will be writing down, that's why it's known as the floor function also. We always write the integer that is at the lower level, not at the higher. That's the smallest integer function, which we also known as the ceiling function. Alright? And similarly, what will be a plus h? So a plus h, of course, again would be a. That's, for example, like 2.2 again would be what? 2. Or let's say 2.7. 2.7 also would be 2. Now from 2, if we subtract 2 minus, let's say, if our value a is 2, so slightly less than 2, let's say 1.9, so that's going to be how much? 1. It's 2 minus 1, that's why 2 minus 1. And slightly greater than h, that's, let's say, 2.1, that will be again a, that is 2. Alright, I hope you've understood that, because this concept will be needed. Okay, so alright then, so this is what we will be dealing with in this particular question. You got that or not? Greatest integer function. Once again, I'll repeat. For example, our point a is 2. So at a, this function 2 would be, of course, 2. That's the greatest integer function, that's less than or equal to x. So we write down the nearest and the smallest integer that is less than or equal to x. Now if we subtract a small interval 2 minus 0.1, then that will be 1.9. So definitely that will be what? 1. Or in other words, 2 minus 1. That's why 2 minus 1, 1. And if it's a slightly greater than integer, 2 plus, that's 2.1. So that would be what? What are the nearest integers here? 2 and 3. Definitely we will be writing down lesser integer, that is of course 2. Same here, what are the integers? 1 and 2 in between this, isn't it? So the 1.9 lies between 1 and 2, these two integers. So we will be always writing down the less than integer 1. So that's how it comes. Okay, I hope that is clear. So now time to prove that it is discontinuous. Alright then, so let's begin. At a, function g of x, g of a, so that would be a minus mod of a. So that, of course, a minus a, that would be how much? 0. Alright, but anyway, let's continue now with the left hand limit. Left hand limit would be limit x tends to slightly less than a f of x, sorry, g of x. So that would be limiting value as h tends to 0 for a very small interval. So that's going to be a minus h. So a minus h would be, as per the function, limit h tends to 0. Now what is the function? X, that is a minus h minus modulus, the greatest integer function of a minus h. So that would be limiting value as h tends to 0, a minus h minus a minus 1. This one I've already given you, isn't it? A minus h would represent a minus 1 for this particular function, greatest integer function. So that would leave us with limiting value as h tends to 0, a minus h minus a plus 1. So that would be limiting value a, that's minus h plus 1 as h tends to 0. So this would be 1. Alright, then what about the right hand limit? Limit as x tends to a plus for g of x. So that would be limit as h tends to 0, g of a plus h. Of course, if we can just prove the right hand limit, left hand limit not equal, that's enough. So that would be limiting value as h tends to 0, that would be a plus h minus the function a plus h. So this one, what did I give you? Limit as h tends to 0, this would be a plus h. For this, of course, would be a. So a cancels. We have limiting value as h tends to 0. So that would be how much? 0. So now you can clearly see that the left hand limit and the right hand limit are not equal. So the left hand limit and the right hand limit definitely are not equal. So therefore, g of x is discontinuous. Okay, got it? Alright, done? Fine. You can pause the video and write down also. Please, my dear students, do study, okay? Do make the most of your time because lockdown just keeps on extending. So this is the best opportunity actually to be, if you look at it positively, to, remain at the peace of your home and then study. No pressure. Is the function defined by, it can be very tempting staying at home, but as I say, keep a time frame, keep a limit, manage some time, enjoy with your friends. Of course, I cannot say enjoy with your friends because you're not allowed to go outside, but still then, like, you can play games, refresh yourself, watch TV, but at the same time, do not forget the studies. Is the function defined by this continuous at x equal to pi? So let's just begin. F of pi, so that's going to be pi square minus sine pi plus 5. Sine pi is 0, so that's going to be pi square plus 5. Left hand limit, that is limiting value as x tends to pi slightly less than pi. That will be limiting value as h tends to 0, f of pi minus h. So that would be limiting value as h tends to 0, pi minus h whole square minus sine pi minus h plus 5. I'll continue here. So limiting value as h tends to 0, that's pi square minus 2 pi h plus h square minus sine h plus 5, because sine pi minus h, sine pi minus h, second quadrant sine remains sine, so definitely it's sine h. So now alright, that's done. So let's use the value of h tends to 0, so that will be pi square minus 0 plus 0 minus sine 0 plus 5. So that would be pi square plus 5, because sine 0 is also 0. So again we get pi square plus 5. Okay? Done? I'm going to rewrite over this only. Alright, you can pause the video there. Okay, now the right hand limit, I'm going to just overwrite here. Right hand limit will be slightly greater than pi, so that's going to be pi plus h, pi plus h, pi plus h. So that will be pi plus h, so sine pi plus h would be second, this will be third quadrant where all similarity, so sine is positive, so that will be, negative, so that will be minus of minus sine h. So if you just substitute, that will be plus, answer will be again same. So now what do we have here? We can now give the conclusion that since all the values are equal, left hand limit, right hand limit, so since limiting value as x tends to pi minus f of x is equal to limiting value as x tends to pi plus of the function is equal to pi plus pi square plus 5, that is the value of the function, then what can happen? The function is continuous at x equal to pi. F of x is continuous at x is equal to pi. Alright, okay. Let's move on to the next question now then. That would be question number now 21. Question is discuss the continuity, of the following functions. Discuss the continuity of the following functions. Number A, f of x is equal to sin x plus cos x. So we'll be taking one general point at A, such that A belongs to the set of real numbers. Now, but before we really start the left hand limit and the right hand limit, what we will do is we will first try to simplify this particular function. That way it will be easier for us also. So simplify in a sense like trigonometry. So what I'll do is maybe I'll multiply by root 2. So root 2. Sorry, I'll multiply by root 2. So that will be 1 by root 2 sin x plus 1 by root 2. I guess these operations you know. So that will be root 2. That is sin pi by 4 sin x plus cos pi by 4 cos x. Because 1 by root 2 is cos 45, isn't it? 45 is pi by 4. So sin A cos B. Okay, I'll just exchange this one. Instead of sine, maybe I'll just use cos. Cos pi by 4, sin pi by 4. That way, of course, we can do it the either way also, no problem. So I'll just use this. So sin x cos pi by 4 plus cos x sin pi by 4. It will be better for us because in that case we can use this as root 2 sin A cos B plus cos A sin B. That is sin A plus B. I guess you remember, isn't it? Sin A plus B would be sin A cos B plus cos A sin B. So that one we are using. Alright, so our function is simplified. So now let's test at x equal to a, such that of course a belongs to the set of real numbers. So f of a would be root 2 sin pi by 4 plus a. Alright, let it be as it is. Now let's check the left hand limit. Limiting value as x tends to a minus f of x. So that will be limit value as x tends to 0 f of a minus h. So that will be limit as h tends to 0 root over of 2 sine of pi by 4 plus a minus h. So root over of 2, limit h tends to 0. Maybe I'll just arrange this. Sine of a minus h plus pi by 4. I mean a plus pi by 4, that will be better. So a plus pi by 4 minus h. Now again, the same formula that we will expand, but this time for a minus b. So a minus b would be simply this. So let's expand. Root 2, limit value as h tends to 0. Just checking, sine of a plus pi by 4 cos h minus cos h, sine h cos a plus pi by 4. Now we can use the value of the limit h tends to 0, so that would be sine of a plus pi by 4 cos 0 minus sine 0 cos of a plus pi by 4. So that is root 2. Cos 0 is 1. So we are left with sine of a plus pi by 4. And sine 0 is 0, so that value disappears. So root 2 sine a plus pi by 4. So similarly, I think this was the same as f of a, because f of a also I think f of a also we got root 2 sine a plus pi by 4. Alright. Okay, now I'll again redo over this right hand limit, that is a plus h. So nothing much changes, a plus h, once you get used to it, no? A plus h plus. So again, this is again 0, so again we get this. So it's quite simple, okay? It's very simple. Of course, your basic concepts have to be very strong. Again, I repeat that every time. So your concept should be very strong. So here also we'll be definitely getting the same value, because a plus h plus a plus h plus. So here it's nothing much changes. This is just plus, so that's when we sine a plus b. So that's when we just plus. But it won't matter because sine 0 is always 0. So yes, it was discussed the continuity. So the left hand limit is equal to the right hand limit is equal to value of the function at a. So hence f of x is continuous at x equal to a, such that a belongs to the set of real numbers. That means for all points of real numbers, the function is continuous. Simple as that. So of course, yes, slightly lengthy, but it doesn't matter, isn't it? It's quite simple. Again, as I say, concepts have to be very, very strong. Alright, finished, my dear friends and folks. Let's move on to second one you do. Okay, the second one is exactly the same. Alright, so the second one is going to be exactly the same, so you can do that, only plus minus will be different. Alright, so we're gonna move to the third question. Alright, okay, so let's go move to the third question, that is number 3, that is number C, that is f of x is equal to sin x into cos x. So this one also we are going to simplify. This one also we are going to simplify a little bit, and after that we will continue the solution. That way it becomes a lot easier. Alright, let's move in. So that will be f of x is equal to 1 by 2 into 2. Of course you have to know the sine trigonometric formulas. So that's 1 by 2 sine 2x. At x equal to a, again a belongs to real numbers. F of a would be 1 by 2 sine 2a, let it be as it is. And let's move on to the left hand limit, that is limit as x tends to a minus f of x is equal to limit for a very small interval h tends to 0, f of a minus h. So that will be limit value as h tends to 0, 1 by 2 of sine 2a minus h. So that would be, okay, 1 by 2 I can take out, come on, limit as h tends to 0, sine 2a minus 2h. So that would be 1 by 2, limit as h tends to 0, sine 2a minus h, just now we have done sine 2a cos 2h minus cos 2a sine 2h. Whew. So now we can use the value of h. So that will be 1 by 2 sine 2a, h tends to 0, so again cos 0 minus cos 2a, again sine 0, so sine 0 is 0, so we are left with 1 by 2 sine 2a, cos 0 is 1, exactly the same. Okay? Chalo. Again, I'm going to use that shortcut only. I'm a very lazy person. So, next. Finish, no? Alright, next, right-hand limit. Right-hand limit will be limiting value as x tends approaches from the positive side, a plus. So that's going to be for a very small interval, h tends to 0, f of a plus h. So that will be 1 by 2 sine twice of a plus h. So that will be 1 by 2 limiting value as h tends to 0, sine of 2a plus 2h. So nothing much changes. Again 2a plus 2h. So again, as we use the interval h equal to 0, again we get the same value. So left hand limit is equal to the right hand limit is equal to value of the function a. So f of x is continuous at x equal to a, where a belongs to the set of real numbers. So hence this is done. So hence f of x is continuous at all points, Alright, so this is how we do. So I think you're getting used to it slowly, ain't it? Right, so I think that's going to be enough for today. Okay, so we'll wind up here for today. Next, I think we'll need 2 more sessions. I'll try to finish in 2 more sessions the concept of continuity, exercise solving. Alright, so thank you so much, and don't forget to subscribe and like also. Till then, bye bye, stay safe, wear your mask.